Hello everyone and welcome back to my BPHO video series. In this video, we are going to tackle question 1I from the 2018 British Physics Olympiad. Let's dive in. First, let's read the question. Two resistors and two cells are connected in the circuit shown in figure. One cell has an EMF of 2.0 volts and an internal resistance of 1.0 ohms. The other cell has an EMF of 1.5 volts and an internal resistance of 0.5 ohms. The resistors are connected in series, and the point between them is earthed, meaning it is at zero potential. The question asks us to calculate the three things. 1. The current through the cells. 2. The potential difference across each cell. And 3. The potentials at points A and B, relative to Earth. First, let's draw a more detailed circuit diagram that includes the internal resistances of the batteries, as shown here. To calculate the current, we will apply Kirchhoff's second law, which tells us that the total EMF in a loop equals the total potential drop across all resistors in the loop. The total EMF is the sum of the two batteries, 2.0 volts plus 1.5 volts. Now, the resistance in the loop includes 5 ohm for the first resistor, 3 ohm for the second resistor, 1 ohm for the internal resistance of the first battery, and 0.5 ohm for the internal resistance of the second battery. Using Ohm's law, voltage equals current times resistance. We get the PD across each resistor in the loop, and the sum of the PDs equals to the sum of EMFs in the loop by Kirchhoff's second law. So we get the equation 2 plus 1.5 equals I times 5 plus I times 3 plus I times 1 plus I times 0.5. Solving the equation, we get the current is approximately 0.368 amperes. Now let's find the potential difference across each cell. In other words, the terminal voltage. To do that, we use the formula terminal PD equals EMF minus IR, where IR is called the loss volts across the internal resistance. For the first battery with an EMF of 2 volts and an internal resistance of 1 ohm, the terminal voltage V1 is 2 volts minus 0.368 times 1, which equals 1.63 volts. For the second battery with an EMF of 1.5 volts and an internal resistance 0.5 ohm, the terminal voltage of the second battery is 1.5 volts minus 0.368 times 0.5, which equals 1.32 volts. Now let's calculate the potential difference across each resistor. Then use that to find the potentials at points A and B relative to Earth. First, the potential difference across the 5 ohm resistor is 0.368 amperes multiplied by 5 ohms, which equals 1.84 volts. Next, the potential difference across the 3 ohm resistor is 0.368 amperes multiplied by 3 ohms, which equals 1.11 volts. The point between the two resistors is connected to Earth, meaning it is 0 volts. Since potential drops along the current in the resistor, so point A is above the earth point by 1.84 volts. Its potential is positive 1.84 volts. Similarly, point B is below the earth point by 1.11 volts. Its potential is negative 1.11 volts. And that's it for the question. Thanks for watching. I'm Physics Michael, and I will see you in the next video.